In this tutorial, we want to solve this problem that cuts across geometry, trigonometry, and mensuration. We want to find the length of the arc QR, the perimeter of the sector, the minor sector, and the area of the shaded portion, given that the circle PQR has center O and angle QPR is 72 degrees. To make this solution a reality, we need to make some constructions, and that would be to join O to Q and O to R. Now that we have joined O to Q and to R, OQ and OR are radii of the circle. Note that length of arc for arc QR is going to be the angle formed by the arc QR at the center of the circle, which is angle QOR, over 360 degrees times 2 pi r, the radius of the circle. However, we need to find the angle at the center of the circle, which is angle QOR. Angle QOR is going to be twice the angle at the circumference, which is angle QPR. This is because the angle at the center of the circle is twice the angle at the circumference. So angle QOR is 2 times 72 degrees, and that is 144 degrees. Now, with the radius of the circle given as 35 degrees, arc QR is going to be 144 over 360 degrees times 2. We're told to use 22 over 7 for pi, then times 35 in centimeters. This gives, when calculated, 88 centimeters as the length of the arc QR. The second thing to calculate is the perimeter of the segment QR. We already have the length of the arc, so we need the chord QR to add to it. And to do this, we need to first calculate the angles OQR and ORQ. But here, OQ is equal to OR because they are both radii of the circle. And as such, triangle QOR is isosceles. And if triangle QOR is isosceles, then it follows that angle OQR is equal to angle ORQ. This is because they are base angles of the isosceles triangle QOR. And we also know that the sum of OQR and ORQ and QOR must be equal to 180 degrees for being the angle sum of a triangle. And with QOR being 144, it follows that OQR added to ORQ must be equal to 180 minus 144 degrees. Therefore, the sum of OQR and ORQ must give 36 degrees. And because the two angles are equal, then OQR is equal to ORQ, which is 36 degrees divided by 2, and each of the angle is 18 degrees. Now, with these angles being 18 degrees, this is 144, and the radii are both 35 centimeters. Then we are going to apply the sine rule in order to get the length of the chord QR. That is the side OQ over the sine of the angle facing OQ, which is the angle ORQ, according to the sine rule, must be equal to the side OR divided by the sine of the angle facing it, which is sine OQR. And that finally must be equal to the chord QR divided by the sine of the angle facing it, which is sine QOR. This simply means that 35 centimeters over sine 18 must also be equal to OR, which is another 35 centimeters, being the radius, over sine 18 degrees, the angles that we said were equal. And that must be equal to QR over sine 144 degrees. We just take any one of 35 centimeters over 18 over sine 18 and equate it to QR over sine 144. But the sine of 144 being in the second quadrant is positive, so that is written as plus sine 180 minus 144 degrees. This is 35 centimeters over sine 18 degrees being equal to QR, the side we want to find, over sine 36 degrees. When we cross multiply and divide both sides by sine 18, we have the side we are looking for, the side QR, to be equal to 35 centimeters times sine 36 degrees over sine 18 degrees. You can pick up your calculator to punch these values and find that to three significant figures, QR is 66.6 centimeters. And we record QR being 66.6 centimeters, therefore, the perimeter of the segment will be equal to arc QR plus chord QR, and that is 88 centimeters plus 66.6 centimeters, giving 154 centimeters to 1 decimal place. That is the perimeter of the segment QR. To find the area of the shaded portion, we'll find the area of the sector QOR and take away the area of the triangle QOR from it. Now the area of the sector QOR is angle QOR divided by 360 degrees then times pi r squared, and that is 144 degrees divided by 360 degrees times 22 over 7 then times 35 centimeters all squared. When calculated, this gives 1540 centimeters squared. And as for the area of the triangle QOR, we are going to use half of the side OQ times the side OR times sine QOR. So the area of this triangle is going to be half multiplying 35 centimeters for OQ, 35 centimeters also for OR, and the sine of 144 degrees. This is going to be the product of half and 35 centimeters, multiplying another 35 centimeters and multiplying sine 36 degrees, being in the second quadrant. And when these are calculated all together, it is 360 centimeters squared when we round it to three significant figures. Finally, the shaded area is going to be the area of the sector minus area of the triangle. And why the area of the sector is 1540 centimeters squared, area of the triangle which we subtract is 360 centimeters squared, and that gives 1180 centimeters squared as the area of the shaded portion. Leave your thoughts and your comments in the comment section. We will attend to them. Make sure you subscribe to this channel and hit the notification bell so that you can be updated from time to time concerning our math tutorials. But for now, have a lovely day.